Introduction to greedy algorithms.
Greedy algorithms make the best choice available at each step to solve a problem. They're fast, easy to understand, and used in many real-world applications. Let's explore 5 classic greedy algorithms that every programmer should know, along with how they work and where they're used.
Kruskal's algorithm, building minimum spanning trees.
Kruskal's algorithm finds the minimum spanning tree of a weighted, undirected graph. By always choosing the shortest available edge that doesn't form a cycle, it connects all nodes with minimal total weight. This method is used in designing efficient networks, like electricity grids or computer networks.
Prim's algorithm, growing minimum spanning trees.
Prim's algorithm also builds a minimum spanning tree, but it grows one edge at a time from a starting node. At each step, it adds the lowest weight edge that connects the tree to a new node. Prim's is popular for network design and is well suited for dense graphs.
Dijkstra's algorithm, finding shortest paths.
Dijkstra's algorithm finds the shortest path from a starting node to all other nodes in a weighted graph. It always selects the node with the smallest known distance. It's widely used in mapping, GPS navigation, and telecommunications to find quick, efficient routes.
Activity selection problem, maximizing tasks.
The activity selection algorithm chooses the largest possible set of non-overlapping activities from a list, such as scheduling meetings. By always picking the next activity that finishes earliest, it maximizes the number of tasks scheduled. This principle is useful in resource allocation and planning.
Huffman Coding, efficient data compression.
Huffman Coding creates efficient, variable-length codes for symbols based on their frequencies. At each step, it joins the 2 least frequent symbols. This greedy approach compresses data by assigning shorter codes to common symbols. It's the foundation of popular file compression formats.
Conclusion: the power of greedy choices.
Greedy algorithms provide simple and effective solutions for many problems, from building networks to compressing data. While they don't work for every scenario, their efficiency makes them key tools in a programmer's toolkit. Try implementing these classics to deepen your understanding of algorithm design.